Okay, so what we're going to be doing today is testing the reactivity of these metals with water, diluted sulfuric acid, copper sulfate, and then this column right here is going to be the control, and we're not going to add anything to it. Now remember, a chemical reaction occurs if there's a release of gas, if there's a color change, an odor change, a precipitate is created. By themselves, they're not necessarily a chemical reaction, but when you have several together. So we're looking to figure out which of these is the most reactive. And I'm going to start with water. Some of these reactions take a little bit of time. And once I put the liquid in, I'm going to make sure not to use my fingers because I don't want to get hurt. So we're going to use tweezers, not fingers. So I've got some floaters, so I will be using my tweezers in just a moment to fix those. Next, I'm going to add the diluted sulfuric acid. I've diluted it for safety reasons, but we should still see a reaction from some of these. Okay. Next, we'll use copper sulfate. We'll let these react for just a moment. Copper sulfate is made by combining copper with sulfuric acid, but it will have a different reaction than the sulfuric acid because it is a different compound. It also has a very different color. It is a bright, bright blue. All right, let those initial bubbles settle out so that we can see what happens. All right, use my tweezers to make sure these guys are in their liquids. Okay. I've apparently spilt something, so I need to make sure to neutralize that. So if you look, you can see here we have some bubblings. Here there's fizzings. I know it's really hard to see. That magnesium's still in there, but it's fizzing like an Alka-Seltzer tablet would fizz in water. In this one right here with the magnesium, there's this brownish, orangish precipitate happening and some black starting to form, and definitely some bubbles because it wants to float. Bubbles are an evidence of gas being released or created. We've got bubbles here with the water in the tin. Bubbles. So some of the reactions are really slow, and some of them are a little bit faster, and some of them are much faster. What's really cool is when you look at zinc in the copper sulfate, it's turned black. Okay. Magnesium has also had a color change. It's definitely getting darker. Definitely bubbling. Here's tin with its bubbles down here. There's a couple of bubbles here. One nice big bubble on this one. Doesn't seem to be a lot happening with the aluminum in the water. It's not as reactive in there. One interesting thing we discussed in class is that some of these metals that are shiny on their own right get their luster changes. They don't necessarily change color, but maybe they appear shinier. So like that first layer that has oxidized has been kind of taken away. So you can compare them to the control. This is what it looked like before we added any liquid at all. And then when it's sitting in the liquid, what it's actually looking like. I'm going to see if I can turn on a light here. See if that helps us see anything. Not so much. We'll turn that off. Get a little less bright. No, all we got is glare. So write down your observations and which do you think is the most reactive? Okay. Which do you think is the most reactive across all? So is zinc the most reactive metal? Copper, aluminum, iron, magnesium, or tin? With all three of their reactions combined, which would you say have the most reactive element? And look, this little magnesium ribbon is starting to not be there anymore. Some precipitate, got some color change on this one. Definitely color change here. When we look at the copper and the copper sulfate, not a whole lot going on. Lots of little bubbles here. One big bubble, a few big bubbles here. That means this is a slow reaction. When you have just like one big bubble, that is a slow reaction. When you have lots of tiny bubbles and fizzing, that's a faster reaction. They're more reactive when it has lots of little bubbles. Okay? Let me know what you think. Let's see if I can get this to work.